welcome to the second of our Nanode weekends. This weekend we're going to be focusing on applications. This presentation is really just to give you some idea of the background of the Nanode project, who we are, why we set it up, and where we hope to go with it. So, Nanode was conceived, let's say, about this time last year. It was the desire to have a much lower cost Ethernet connectivity for an Arduino type open source platform. So essentially we took the existing EtherShield that used the microchip Ethernet controller, and we put that on the same board as the Atmel 80 Mega, producing a board that is substantially compatible with Arduino and has Ethernet connectivity. And by doing this, we were able to bring the cost right down to around £20, making it very cost effective and very attractive to schools, colleges, hackspaces, amateurs and enthusiasts. So this slide set is one that I put together for a presentation that I did in early April to Patchbay, so there may well be some references to Patchbay as we go through. Nanode, it's a low-cost network applications node. It's been based on the Arduino open source platform, such that it will be familiar to many developers and enthusiasts. It's intended to be a kick-starting device for what's come to be known as the Internet of Things. And we look at it as a starter kit to develop web connectivity applications. So it's based on versatile open source hardware and firmware, and we've tried to put it together at a price of about £20 or $40 in the States, in order to make it cost effective and attractive to a wide target market. So the first Nanode, it was built up on a breadboard in August of last year, so just a year ago, and it consisted of the Atmel 80 Mega, the Ethernet controller from Microchip, some Blue Logic, an Ethernet connector, the mag jack, and an FTDI USB to serial cable to program the sketches into it. And that's a picture of the first prototype. So having been able to put that together for about £20, we realised that we had the potential to then put it onto a printed circuit board and make a low-cost, easy-to-build product. And the next slide is the result of that first iteration of the PCB. So on the left-hand side, we've got the Ethernet connection, the mag jack. We've got a four-way terminal block, which allows you to power the board and also connect it in a serial slave mode to other such devices. We've got the FTDI connector coming in from the top right-hand side, and a USB connection for powering the board in the middle of the right-hand side. The board has the standard 6-way and 8-way single inline shield connectors, so you can fit standard Arduino shields onto the Nanode. So just a quick update of how we got to where we are. Last August 2010, the first prototype on the breadboard. In March of this year, we produced 10 prototypes on the PCB. We launched that at the Patchbay 24-hour hackathon early in April in central London. We then retired to the hills of Snowdonia over the Royal Wedding weekend and over Easter weekend to further develop the product. So that we then launched with an initial production run of 145 kits, which were put together mainly by members of the London Hackspace. And that was done the first weekend in June over at the London Hackspace, where between us we built about 35 of the first batch. Last month, July, we shipped 195, and we've got our first and only exclusive reseller in the USA, a company called wickeddevice.com. They're based in Ithaca in upstate New York. Ithaca is the town where Cornell University is based, so it's a hotbed of academia up there. And then moving ahead, this month we've got this event, the Nanode Applications Weekend, here at the Centre for Creative Collaborations in central London. And this month we expect to ship just over 200 kits. A quick list of some users' applications. One of the attractive things about Nanode is it offers a very low-cost platform to be able to get your data up to the internet, and this is something that the guys from openenergymonitor.org discovered early on in the project, and they have been building up their wireless open source energy monitor, Emon TX, and that uses the Nanode to get the data up to their energy monitoring server. Andrew Lindsay, who wrote much of the updated EtherShield library, he has now upgraded that to include a DHCP server. Some other developments include the UIP. That's an alternative implementation of the IP stack. And Stephen Early, who is associated with the London Hackspace, he's put that together, and that offers a more flexible IP stack, and also there's already an implementation of IPv6 with that. So looking ahead to the future, it looks like that stack implementation may be the one to follow. Andrew Lindsay, a very prolific code writer, has just recently demonstrated an online bootloader which allows you to upload sketches to your Nanode using a TFTP server. And Wicked Device in the US, working with Patchbay, are building up a multi-sensor module that will allow Patchbay customers to do simple remote sensing applications using a low-cost product. Last month, one of the things we did is we had a trial batch of Nanodes made out in China, or at least the PCBs came from China, and this is the first and only red Nanode that's in the Western world. Looking ahead, we've got a number of events throughout August and September that we're going to be attending with Nanode. We've got Boak Camp in the middle of August, the Brighton Mini Maker Fair in September, and then Nanode will be making its appearance at the Maker Fair in New York City in the middle of September. A couple of UK hack spaces in Birmingham and Nottingham, and then because Nanode is an open source product, we're getting together with the guys from the Open Source Hardware Users Group at the end of October to present it as an example of open source hardware. Future plans of Nanode, well, we're looking to do production and kitting out in China for world distribution. We want to set up a network of international resellers who can purchase Nanodes in bulk and sell them on to their local markets. We've already had some interest from some organisations in France and Germany and Switzerland, as well as our colleagues in the US at Wicked Device. Kits would be shipped in bulk and then pre-packed, ready for resale by those resellers. The existing Nanode is Nanode 5. We're going to upgrade to Nanode 6, substantially keeping the same PCB format, but we're going to include a wireless connectivity option and additional memory, which allows the online download of sketches to be achieved. And in the next 3 to 6 month timescale, we're looking at producing a modular Nanode, which is a 32-pin dual inline format module, which will have RF connectivity on it, and it's most likely to be based on the Atmel Mega 32 U4, which is the enhanced Mega core with the USB on it. So whilst keeping the existing starter kits, we are looking to offering nanotechnology in different formats to make it more appropriate to inclusion in different devices. Okay, the second part of the slides here are more appropriate for when this was a Patchbay talk, so I'll rattle through those. Patchbay is an open data hosting system which allows small resource-limited devices like the Nanode to get their data up to a web-based application, and that data can then be visualized or it can be disseminated to other small microcontroller-based devices. So the analogy is thinking of it as a great big telephone exchange or switching center for different sorts of data. And the very useful thing about Patchbay is that all of the complex functionality of handling data and distributing it to a wide range of subscribers is handled by the API cloud-based application, which means that even very small, low-cost, almost trivial hardware like the Nanode can be used in quite complex data sensing and remote control and monitoring applications, even with resource-limited hardware. So, for example, this slide shows that we have the Nanode on the left is a publisher, and it's receiving sensor data, which might be temperature, humidity, soil moisture information. It then passes it through its Ethernet connection and the internet up to the Patchbay API. That information can then be subscribed to by one or more devices, and in this case there is one subscriber which takes the information from Patchbay and uses it to do some physical form of application control. In this case, the example is an RGB lamp, which can be used to show, for example, energy consumption, and we can change the colour and the hue of the lamp according to perhaps how much instantaneous energy we're using. So green would be considered to be fairly neutral, whereas orange and red colours would be used to signify excessive rates of energy consumption. So it's a very simple application of an ambient lamp being used to visualise not so much quantity, but the quality of the energy that's being consumed. Okay, one or two technical details on this slide. The Nanode, it uses the familiar Arduino integrated design environment. It's an 80 mega 328 that's running at 16 megahertz, like the Arduino. We use the microchip ENC28J60 Ethernet controller. It's pin compatible with most Arduino shields. We have some extra I/O capability on it to make it what we term breadboard friendly, so that it can be plugged into a breadboard for prototyping just along one side, the top edge of the Nanode PCB, allowing a more simple connections to be made to prototype hardware. We have a local serial network which allows several Nanodes to be connected together in a master-slave topology. Wireless has been added as a low-cost shield option, and as I said, it's programmed with the Arduino IDE, a familiar IDE for a lot of people who are exploring the physical computing world. Here's an example. This is actually one of the first Nanode prototype PCBs, and there we've got it running the Nokia 3310 LCD display shield, which is available worldwide at very low cost. Nanode was built on a low-cost two-layer PCB. We used Eaglecat design tools to do it. These are more or less universally accepted as being the preferred choice of tools for amateurs and enthusiasts. It's an open source product, so all of the PCB data is made available. Nanode was designed for low-cost construction, DIY construction. We use entirely through-hole and conventional mounted components. And for the ICs, we use the dual line packages. All ICs are socketed. These parts are readily available. You only need basic tools and elementary soldering skills to be able to put one of these together in approximately 2 hours. It runs off 5-volt USB power, or we can accept up to 12 volts external power. The applications code is available online, and as a kit to Hackspace is under £20. I'll just skip through this. We've got the schematics online, open source hardware. As I've said, everything is freely available. And then just moving on to some applications. It can be used for smart sensor networks. remote temperature monitoring, humidity, soil moisture. If you've got a typical analog sensing application, Nanode can be applied to that with relative ease. The use of the master-slave network, where nanodes can be connected together with little more than 4-core telephone extension cable for fixed networks, allows a very low-cost network to be implemented. We're looking at various wireless options, of which the Hope RFM12B, which is available at all international wireless frequency standards, that's proving to be a cost-effective winner for wireless. So we open up applications such as remote control, energy monitoring, home automation, and the idea of using the Nanode as a platform to give momentum to the Internet of Things. Okay, so this next slide, just very quickly, it shows one Nanode acting as a publisher, sending data up to Patchbay, and perhaps 3 separate Nanodes, possibly widely spaced geographically, that are subscribing to that published data and controlling perhaps 3 different applications, such as actuators, display, or some other visualization process. Here we have one master Nanode that is subscribing to the published data, and it has 3 slaves that are connected to the serial bus. And again, for fixed networks, this is a very cost-effective way of having fixed networks for home automation. We spoke a little about wireless. Nanode can be used as a wireless bridge, and this is becoming an increasingly popular application, where we have currently we've got the option of a low-cost wireless shield, which gives the existing Nanode two-way wireless connectivity. And finally, Nanodes, obviously more fun in pairs. So the Nanode project, it's been a collaborative project between software engineers, hardware engineers, applications people, and we've done it as a loose collaborative project involving a number of different organisations. In particular, the hack spaces in the UK, and also we've had a lot of support from Patchbay, the open data company. They've been very supportive of what we're trying to do. So that's some of our co-collaborators. Okay, that finishes this talk.